You're a math teacher, so why do you have maps in your room?
Because I always talk about the world, and some kids are like, what? Mauritania, where's that? Georgia, where's Georgia? We were talking about Georgia yesterday, right? In this class?
I wasn't here.
Oh. Georgia is right there. That you're in the wrong continent, my friend. Africa is here. Georgia is right here.
Who are the languages in America?
The country Georgia.
Wait. No, there's like the state. There's a country. You going to Las Vegas again?
You going to 8th grade?
Yeah.
You sure?
No.
Okay.
I don't think so. Well, she's not.
All
So
right.
she's not getting custody.
Hey, we started yesterday's class with a quick class on how to calculate GPAs. We briefly talked about, at least at our school, what it takes to move on to the next grade. That was all explained to you. I do that every year towards the end of the year for 7th and 8th graders. Soraya, Hoodie, Danny, Jacket. All right. And the hat too, Danny, but
No, it's for the play. It's like the promotion for the play.
okay. What are you, Danny?
Huh?
What are you? Are you really a snowman?
No,
I
we
didn't-
did it as a snowman. Not in the play now. No, she's a child.
Oh,
She's
sure,
playing
sure.
one of the main things.
What character are you, Danny? Susan. One of the main characters.
Yeah.
I didn't know
I'm
that.
the other main.
I look forward to seeing both of you. And who else?
You won't see me, but I'm in it.
Thursday because it's
The
the teacher appreciation one. Okay. So start off with that speech that was meant to do two things. One, it's meant to inform you, obviously, and the second thing was well, at least so publicly, the kids that they never hear it enough, maybe from home or from school, that they hear it at least another time of like, we are not at a school where you breathe oxygen and you pass. We are at a school that there are standards, and you will be rewarded, or what's the opposite of rewarded? Penalized for your year's worth of work. We are in school for 10 months out of the year, 10 months. Okay? When you get to high school, it's the entire year because we give summer homework, right?
What?
9th grade, 10th grade, 11th grade, 12th grade, they go to summer with homework. So the 9th graders have to read a book. It's about that thick, and they have to do a report. They read, I believe it's the Odyssey. 9th graders. I forget what 10th graders read.
Iliad?
No, they do the Iliad during the year, but they do the Odyssey during the summer. I believe that's right. I could be wrong. And then there's history homework as well too. As 7th and 8th graders, you don't have a summer reading list, but just you will. So back to the reward and penalize. Like you get rewarded for doing work at this school. You don't get rewarded for showing up. And some of you have been kind of just showing up. And in class, it's like you have to be told to do your work. And you won't do any work unless you're told to do it. That's what lower school is like. Like the teacher has to literally, okay, step one, grab your pencils. Step number two. You guys got experience 6th grade, right? Here? How many people are here for 6th grade?
Yeah.
Richard, what did they make you do last year? Like literally, what did they make you do? Because I saw you, because you were so tall, right? You and Soraya both. What did they make you do? Literally for almost everything in 6th grade. Because your face expression held it the entire time. I would see Richard.
Oh, yeah, that definitely wasn't me.
No, it was you.
It was.
I'm just saying. I'm just saying. They make a very intricate and detailed prescription. Jake.
It's my winter accessory.
Jake. They make a specific prescription for everything. How to go to the bathroom, how to hold your pencil, where to put your stuff on your desk, everything. We don't do that in upper school because, well, you guys, what, got 2 years of it? 5th and 6th grade, right? By the time that you've done it for 6 years, right? Hopefully you're on track for success in upper school because at least in our school, we don't teach easy stuff, we only teach hard stuff, right? The language arts is way harder, the history is way harder, the math is actually the same. History is way harder. You walk into a history class, the middle school down the road here, and you see what they're learning. Let's pull out our colors and let's color the map. Right? They don't learn the names of the country, but they learn the Texas needs to be colored green or something like that. You learn a lot more at this school. So the hard work is either rewarded or you're penalized for not doing the work. And so the whole purpose of yesterday was just to let you know of what those penalties could be and how you reach that penalty phase. I said that only because when I asked you to pull out your homework, I literally still have people who didn't do their homework. You don't pass a math class by not doing your homework. Some of you are smart enough in 7th grade to literally just hear what I say, I just kind of pay attention, I kind of get it. That kind of stops when you get to Algebra 1. Like, it's not possible. You don't show up to math class and pass. The way you pass Algebra 1 is that it's weird stuff. I could show you today what we're doing in Algebra 1, you would understand none of it. Like none of it, not a single thing on the page would you understand what we're doing today in Algebra 1. That's in 2 years from now for you guys. If you set up good habits of, I always do my homework, I always pay attention to class, I participate when asked, you'll be fine in Algebra 1, even though it's challenging math, right? If those habits haven't been set up, you don't stand a chance of passing high school, which is kind of a pretty big deal. All right. Do your homework. Not just my class, but all your classes. When it's assigned, you do your homework. Avery? What? We didn't. I got to do a better job today because I skipped collecting in a couple days. All right. So when I collect homework, I want you to turn in every bit of homework that you have. If I haven't collected it, I haven't put zeros in the grade book yet because there was like a day that I know I got Eleanor's and because she came up after, hey, you want my homework? I was like, oh yeah, I forgot to collect. So I will collect all the homework today. Any questions on the homework though? Questions on the homework? It was odds and probability. Devin sent me a chat last night saying, wait, isn't this exactly the same question? And they were the same question, except some of them were asking you probability, some were asking odds. Questions 1 through, I think it was 7 or something. 1 through 8. It was literally the same question. A and B was probability for, probability against. And then C and D were odds for, odds against. It was the same question, just asked 2 different ways. The purpose of that was trying to get you to realize that, for instance, if the probability is one way to win, 5 things that can happen, that's the probability for. The probability against it would be, well, then there's 4 ways to lose out of 5. These 2 added together, this probability will be 1. I should put 5, no, sorry, 5 over 5, which is 1. For odds, it's how many ways to win over how many ways to lose. Notice 1 plus 4 equals 5. That's kind of the relationship between the 2. This is odds in favor. Odds against is this thing flipped. We don't add these 2 for odds. You get 1. But this plus this will equal the denominator. That you should have seen that pattern as you were doing your homework. That's why they had you do those 4 things, even though they didn't ask you about that pattern. All right. Any questions? All right, great homework. Here we go. Very quickly. I'm going to call these out very quickly. No, I'm just going to call out the odd ones. Number 2, right? 1/5, 4/5, 1/4, 4 over 1. Notice the first 2, 1/5, 4/5, they have to 1. And the second 2, 1/4, 4 over 1, are just the 2 fractions flipped. Yeah. Percents are fine. The book only gives it in fractions. Now you didn't do the odds as a fraction though. You just did A and B as percents, right? Yeah. Number 4, 2/5, 3/5. 2/3, 3/2. Number 6, 3/5, 2/5. 3/2, 2/3. Number 8, it's the same answer. 3/5, 2/5. 3/2, 2/3. If you wrote in colon form for the odds, 3/2 is 3-2. Number 10, now we're just back to straight old odds, 1-2 or 1/2. Number 12, 1-1 or 1/1. Number 14, 5-1 or 5/1. 1-2 and 1-1. If you're just writing down what I'm writing down, then you're doing it wrong. All right. The rest of the questions, somehow they take a very easy game and make it crazy hard. It's the card game. They got a deck of cards, you're drawing cards. But instead of having a normal deck of cards, they make up their own deck of cards, and it's complicated. I don't know why they made this one. They should have said a deck of cards. There's 24 cards in this deck, and they got some weird colors and weird numbers. 16 is 1-7. 18 is also 1-7. 20 is 1-5. 22 is 7-17. 24 is 1-1, and the last one, number 26, is 1-5. Yeah. Yeah. It should be reduced. Okay. Habits. Nathan. Habits. Give me a habit that you have. Okay. A habit is something you do repeatedly, right? So, for instance, habits are, we always say, hard to break. If that's something that you always do, you generally, well, there's a reason for it. If your habit of work is, I don't do work, what's going to change when you get a job? Your habit is, I don't do work. What's going to ever change? Just because you got a job, you change your stripes, you say, I start to work now? It just doesn't happen. If your habit is to always, no, I don't do work, you're going to get your first job. The boss is going to say, I need you to do this, and guess what you're going to do? Nothing, because your habit is never to do work. You build habits in everything you do, right? Nothing really changes from middle school to the rest of your life. The same stuff you see going on in middle school happens in life. Every little tiny thing you see that happens in this classroom, it gets done again as adults. Out of a group of people, we got like 26 people here, right? Out of 26 people, how many people always do their homework here? I don't know, it's a good number, right? I'd say half, always, like there's not a single missing homework. Turns out for the population, about half people always do what they're supposed to do, always. They don't speed, they always obey whatever the law is, they turn things in always on time. There's about another quarter of you that, yeah, for the most part, you turn things on time. You got a couple missing ones now and then. Population, the same thing. It's that last 25%. The kids that never turn in homework, right? There's a reason that the prisons are full of people.
Oh,
right?
Really?
There's a reason for that.
For me not turning in my homework, I'm going to go to prison.
Right? Well, obviously, I'm going to the extreme there. But I'm saying, when you look upon this population right here, we can't even imagine that anyone in this room should ever go to prison, right? Where do prisoners come from?
Jail?
That's where they come
I'm just
from.
saying,
I'm so dumb.
every person in prison is jail is where you go before you go to prison.
Exactly, so I'm right.
Those people, they come from the general population, right? There's not like a switch that all of a sudden gets flipped, like whoop, and now I'm a criminal, right?
Oh, I'm a criminal now.
Right?
I got it.
I don't know what the prison population in the United States is, but it's high single digits, if not double digits.
High single digits?
Like 1% of the population. No, it's not 1% of the population. It's high single digits.
Like
Right?
9%?
We can look it up if we want to in a second. I'm just saying, habits, right? Set good habits for yourself. Yeah, the prison thing, that's probably a stretch for you kids, right? But I just want to point out that they come from somewhere. The habits that you set up in middle school will be the habits that you have for life. Hopefully you're setting up good habits, not bad habits. Let's do some math. All right. Antonio's coming around to collect your homework. We are actually, believe it or not, have arrived at the last day of class. There are no math classes beyond today.
Wait, don't we have a
We do.
test?
Technically, I don't teach anything on a test day.
This is our last homework.
This is your last instructional day.
So this is our last homework day?
This is your last official turn-in homework day. Now, we just had a speech about habits. I know for a fact there are a couple of you out there that when I give practice tests, guess what happens? They don't do it. Okay? Let me talk. I know for a fact that no matter how many times I try to point to you heard the word causality before? Something causes something. The people that make a resource card, that do their practice test, that ask questions when there's something on their practice test they don't understand, that's what causes causality. That's what causes them to get great grades. Yeah, occasionally even those kids that don't study can pull out an A now and then if it's something they're familiar with. Okay, but for most students, they have to study in order to do well on a test. Today's your last instructional day. Only thing we have left after today are tests. Okay? And practices for tests or getting ready for tests. So we look at the calendar. You guys are, since they moved field day to Friday, you guys are the recipient of that benefit, meaning that we will not have class on Friday because we will be outside. So that's not your calendar, that's your calendar. So yesterday I said the test was on Friday, but field day is going to take up that place. Your test will be on Monday. Now I caution you, right? We're going to do 2 chapter reviews, Wednesday and Thursday, tomorrow and the next day. We're going to have a field day. That means we're not doing any math on Friday. And then we're going to have the weekend. I'll leave it to you. You're going to show up on Monday. We're taking the test. No tears, no anything. We're taking the test. We're taking the test on Monday.
I thought it was on. Oh.
It's because it's after second period. Because Friday we get out at 2 o'clock. Okay? Some of you are not going to be able to handle this. Hayden, Nathan. You wouldn't study anyway, right?
Yeah.
Jake. Maddie. Wait, I'm not sure Maddie would study either.
I study every single test.
Madison, no.
No matter what.
You guys, the ones that I called out, are going to have to dig deep and understand that there is a good possibility that you will forget everything by Monday. Like literally everything. You guys got to figure this out. We're going to do a chapter review tomorrow and Thursday, and then we're going to have 3 days off, basically. It's up to you. Now, you may do the 2 chapter reviews and like, what is he talking about? I got this stuff down cold. All right. Maybe you can go 3 days without looking at it before we take the test. The stone cold facts are cold hard facts. My mixed metaphors there. The cold hard facts are we're going to take the test on Monday. We're going to have a 3-day break in between the last review day of the test. A resource card, especially for this test, there's formulas involved. Examples from the practice test on your resource card are what's going to help you get through those 3 days. What do you got, Danny? No calculator. Yeah.
Some people wanted to see the video.
And the class. All right.
Class.
And then we're going to do a pre-algebra prep day. It'll just be some instruction. I won't give you homework on that. But, well, I mean, technically there is homework. I don't put it in the grade book. I never put reviews on the grade book because I give you the answers for everything. But for the semester final review, it's going to be, I haven't made up the test yet, but it will be close to 50, 60, 70 questions, multiple choice. I will use the full hour and a half of test period. There'll be kids in here that need the full hour and a half to take the semester final, sorry. Some kids will get done in an hour, right? But plan on, it's going to be a lengthy test. It will be multiple choice though. The practice test that I give you on next Wednesday, Thursday, Friday will look identical to the real test, just fewer questions. What's up?
Will you let us sleep?
No. Most of you are going to be working for the full hour and a half.
The full hour and a half.
Yeah.
Wait,
How many
what if we don't
questions is
finish
there
it?
gonna be?
He just said you do not.
Richard,
50
do I need to
60?
rewind?
Yes.
All right, I have not yet made the test.
Wait,
So what I use are the 2 practice tests as a guide, the 3 practice tests as a guide of how many questions to put on it. I think the majority of the class can handle this many questions. I mean, I make 3 practice tests each day on different material. So the first day is, let's see, I forget if we started with chapter 7, I believe it was after Christmas. So the test will be whatever we did in January all the way up until today.
Oh, okay.
What?
January?
It's called a semester final, not a quarter final. Okay? Christmas, we took the first semester final, chapters 1 through 6.
I did not.
It could be 7, I'm not 100% sure.
Wait,
It's either 1 through 6 or 1 through 7. Anyway, the rest of the book is what we will have this, literally, the rest of the book. So there's a lot of material that we'll have to review. By the way, that material also includes the geometry stuff, the one that had all those formulas. So having a good on all semester finals, I allow you with 2 resource cards, okay? Because there's a lot of stuff to put on. Here we go. Homework tonight, 1 through 12 all.
Why do you not have
Do not try this homework until you get both formulas. A couple of you like to have your book open. You're like, I'll try it. There's 2 formulas. It'll be half the class before I show you the second formula that you will need to do almost every question. Yeah.
In semester 2, did we also talk about like the discounts? And...
We did.
oh no.
But you have a resource card.
Okay.
Your resource.
Yeah, I can't have. Oh, this is not the paper front and back. Just of like 5 months of stuff.
You will.
I did not do good on my last final. I got a C on it.
C's passing.
Not in my family. Not granted yet. I have D's because I promised my mom they'd at least get a few C's.
You can get some C's.
I am. I'm working on it. Not doing my
You
homework.
literally
it's
just said
helping them.
C's are not good, and you just said you
No,
promised
but
your mom
like
you're
no,
gonna
a
get C's.
test. I'm only allowed to have 1 C. Because the rest have to be A's and B's.
Okay. Good luck with that. All right, here we go. I'm going to warn you, a second warning. Hey, there's 2 formulas. One's very intuitive. It'll be the first one we do. Second one is, it's an easy formula. It is required. There's 2 things. Look at me. There's 2 things we do for homework. They don't ask you all about the first one and all about the second one. They take the 2 and they mix them up. So every question could be either Formula 1 or Formula 2. It's going to be half the class before I get to Formula number 2. So if you're trying to do your homework right now, you got to have both formulas to do the work. Today we're going to do something called combined probabilities. Big fancy words. It's a pretty simple concept. So remember, probability is the chance of an event occurring. Here's the formula. Don't write this down yet. It's also the easy one to remember. It's the number of ways to win, not over the number of ways to lose. That's odds. Number of ways to win over everything that could happen. That's basic probability. Oh, by the way, you had that last night with homework as well. Nathan, you with me? Yes. Okay. All right. Recall that we had 3 words for probabilities. The first one was this thing called outcomes. Big fancy word for what can happen when we play the game. There's 8 things that can happen when we play the spinner game. You got 1 through 8. Okay? When we talk about calculating the probability, we're talking about 1 or more of those outcomes. So for instance, the probability of getting an 8, that is an event. An event is 1 or more of those outcomes. That's what we actually calculate. That's why the formula says not probability, but probability of an event. What is that event? Well, that's what you calculate. Lastly, well, it's the same thing. So probability is just, it's a number that reflects the likelihood of the event or the chance of that event occurring. Okay? All right, that's old stuff. We've already seen that. We're going to be doing 2 things today. We're going to be doing multiple events. It's not going to be the probability of getting a 1. All your homework are going to be 2 events. You can do 3, 4, 5, 20 events at once. But tonight for homework, we're going to ask you to do 2 events. Okay? And it's going to be, what is the likelihood of those two events occurring at the same time? Some of them, let's say half, right, can't happen at the same time. Two things that cannot happen at the same time. You've heard the old expression, you can't chew gum and walk at the same time. It's kind of like that. You can. That's going to be formula number 2. Formula number 1 are two things that literally cannot happen at the same time. You cannot be in math class and English class at the same time. Can't be done. Well, no, because math class happens here, English class happens over there. You can't be in the classroom. We're not talking about weird things. Oh, I'm zooming in, right? We're talking about you can't physically be in this classroom and that classroom at the same time. The first formula that we get will be just like that example. You're going to be calculating the probability of two events occurring that cannot happen at the same time. We're going to have a big fancy word for it in a second. The second one, halfway through the class, we're going to be talking about two things that can happen. All right, chew gum and walk at the same time. All right. These are going to be the events that can happen. You're going to be calculating the probability of two things that could happen. It doesn't say they both happen, but they could happen at the same time. Okay. All right, box 1A, first flavor. The first flavor is events that cannot happen at the same time. These are going to be two things that cannot happen at the same time. That's a perfectly fine definition. Math people put a big fancy word for this. The big fancy word for two things that cannot happen at the same time are called mutually exclusive events. If you exclude someone, right, you don't allow them in. Two things that cannot happen at the same time. They each exclude the other one from occurring. If this happens, well, the other thing can't. If you go to math class, you can't also go to English class. Mutually exclusive events. Events that cannot happen at the same time. The hardest thing today for homework is that step number 1, when you calculate the probability, is you got to figure out, is it mutually exclusive or the other word that we'll talk about halfway through the class? That's going to be step number 1. If it's mutually exclusive, you use the mutually exclusive formula. We'll talk about that in a second. If it's not the other thing, well, then you use the other formula. Step number 1 tonight for homework, second time. Figure out if it's mutually exclusive or the other one. How do you do that? You simply ask yourself, do these two things happen at the same time or not at the same time? If they can't happen at the same time, you use this formula. Well, I'll show you here in a second. If they can happen at the same time, you use the second formula. Can you be in this class and English class at the same time? There's two things that cannot happen at the same time. It'll make sense when we play the game, Stan. Okay, we good? Definition? All right. Now, some of you will say, but wait a minute, I can get a 4 and a 6 on a die, right? Because I could roll it 2 times. We're going to say we're playing one game and one turn only. Every game we play, it's one game and one turn. In 8th grade, guess what happens? You play 2 or more games and you play 2 or more turns. Lots of things can happen, which is why 8th grade probability is way harder than 7th grade. A lot of different formulas. 7th grade, you get 2 formulas and odds, so there's 3 formulas. All right. Some examples. Danny says, what does that mean? Danny, I got one die in my hand. I'm going to roll it one time, one game, one turn. Can I get a 4 and a 6 on one roll? So mutually exclusive. Okay. Got a deck of cards. I'm going to pick one card. Can it be the Ace of Spades and the King of Hearts at the same time? Nope, they cannot happen the same. If I pick 2 cards, that could happen. But we're talking about one game, one turn. I have 2 turns to pick 2 cards, right? It could happen. Next year, we'll do that calculation. Okay. One game, one turn. Both things are not going to be able to happen at the same time. Well, how am I going to know? Well, you just think about it. Could they happen in one game, one turn? Okay. Here's the second flavor. Okay. Probability of rolling a 4 or a number less than 6. Can that happen at the same time?
Yes.
Can you get a 4 and a number less than 6 at the same time?
Yes.
By rolling a 5 is not a 4.
4.
You roll a 4, it is both 4 and a number less than 6. Both of those things can happen at the same time. Different formula. We'll talk about it halfway through class. Okay, one game, one turn, both of those things could occur. Probability of choosing a king of hearts or a red card. Can that happen at the same time?
Yes.
King of hearts is red, right? So this is one formula. Things that can't happen at the same time, a second formula. All right, we're gonna do one formula at a time. Okay, one formula at a time. Write this down. You all, this is already in box 1A, right? Box 1B, we're gonna put the formula. The formula for mutually exclusive events looks like this. The probability of either A or B occurring, oh, it's silly simple. It's the probability of A plus the probability of B. A and B are going to be the two events. Literally, the letter A and B are the two events. So you figure out the probability of A occurring, you figure the probability of B occurring, and you add those two together. By the way, you will always have common denominators. It's easy to do. Easy to do. This is for mutually exclusive events. Two events that cannot happen at the same time. If it's mutually exclusive, you use that formula right there. Probability of A plus probability of B. It takes longer for me to read off what's on that slide than to do the math. The math is really simple. Two fractions added together, the fractions will already have common denominators. Oh boy, like I said, it visually doesn't look it visually looks complicated. It's really simple to do. Everybody have it written down? Okay. You must determine tonight for homework whether it's mutually exclusive first.
None of them are mutual.
Most of them, well, tonight for homework, it's about half and half. Okay. Half are mutually exclusive, half are not, but they're mixed together. Okay. Homework won't tell you whether it's mutually exclusive or the other thing. You got to figure that out first. If it is mutually exclusive, you use the formula. How about we do a couple examples first? Yeah, but how about we do a couple examples first? Okay. The probability of getting a red or an even number. Can those two things happen at the same time? Can you be red and even at the same time on this spinner?
No.
No. So they are mutually exclusive. This has to be step one. Because sometimes they can happen and we're going to use a different form. When they're mutually exclusive, we use the mutually exclusive form. That thing right there. Now don't panic. You ready, Danny? I'm going to write what this should now say. No one actually does this. The thing I'm about to show you, no one actually does, but you think about it. This says probability of A and B, but A is red and B is an even number. So what no one does is to write that. All they're doing is telling you what A is and what B is. Most people just say, okay, I know what to do. We add the two probabilities together. I'm just saying that this step that's blinking right now, nobody actually writes. Hey, what's the probability that it's red? Out of, that's odds. 8 is the probability. One way to win, 7 ways to lose would be the odds, but 1 out of 8 would be the probability. So the probability of red is 1/8. What's the probability that's even?
4, 8,
Where are you getting a 4 from?
There's 4 even numbers.
There's 4 even numbers. Okay. Guess what the formula says to do with those two numbers? Look, we already have common, and it'll always work this way. We got common denominators. So what's the final answer? Okay, you tell me, easy or hard?
Easy.
It is easy. By the way, once again, no one actually writes that step or that step or that step. They literally just write 1/8 plus 4/8 and they're done. But you're thinking about this, right? Danny, yes? Okay. Another example. This is a bad example. It's from the book. They should say at the very start, you can't have a two-colored card, even though they do exist. All right. The probability that a randomly chosen solid color card, solid color, one color, is green is 15%. And the probability that's red is 25%. 25%, except they say 0.15 and 0.25. What's the probability that a red or green car is chosen? Can these two events happen at the same time, red or green car? Like you pick one car, can the car be both red and green?
Yes.
It says a solid colored car.
No.
So they're mutually exclusive. They can't happen at the same time. Remember, that's always step one. You got to figure out, is it mutually exclusive? Because if it's not, we have a different formula. Okay? Nobody writes that. Nobody writes that. They simply do the calculation. Read the text. What's the probability that it's green? 15%. What's the probability that it's red?
25.
What do we do with those two numbers?
Over 100.
You can. And she's saying, well, let's write them as a fraction. So 15 over 100 plus 25 over 100, perfectly fine. We get 40 over 100, which is 0.4 or 4%, 40%, sorry. You're just adding two things together. That's it. That's the whole formula. It takes longer to explain it than it does to do it. Okay? All right, box 2, let's do one together. Here we go. Spinner game. Obviously, yours is not in color. Here's the colors. Probability of purple or yellow. Neelius, can those two things happen at the same time? Can you be both purple and yellow? No. You spin the spinner, it can't land on both purple and yellow in one spin. If I spin it twice, I can be purple and yellow. But one game, one turn in 7th grade. Okay. Well, it's mutually exclusive, so I use the mutually exclusive formula. Maddie, what's the probability? Well, A is purple. What's the probability of purple? Out of. Perfect. What's probability, Danny, that's yellow? What? What are we supposed to do with those two numbers? And look, we'll always have common denominators. So it's 2 plus 2, which is 4. 4 over 8 is 50%, or 4 over 8 or a half. Yes? Not complicated. Okay. Mutually exclusive. You take the two probabilities. By the way, this could be 3 events. Probability of yellow, purple, or a 5. There's 3 events. You would add those 3 up together. Okay. You're not going to see 3 events till 8th grade. Box 3, here we go. Step number 1, you got to make sure it's mutually exclusive first. Because if it's not, we got to use a different formula. Jake, read it.
The probability spinning a red or yellow.
Can that happen at the same time?
No, sir.
No, it's mutually exclusive. We've done step 1. So we pull up the mutually exclusive formula. Nobody writes that. Nobody writes that. Right, impress me if you do. My college professor said the same thing when I had this class in college as well too, because nobody remembers it from 7th grade. And he was like, no one is going to write this down. It's too much to write. Right? Probability of red is?
The probability of red is 1 out of 1 of 8.
Okay. Probability of yellow?
2 of 8.
You might want to write those down, right? It says to add the 2, so add the 2. Final answer is 3/8. You're done. Stop me if you're lost. My assumption is we got this. So we just did mutually exclusive. Mutually exclusive. All right, do this one all by yourself. Box 4. Box 4, all by yourself. Get to the answer. Nathan, you got an answer? Can you be odd 2 at the same time?
No.
Can't. So it's mutually exclusive. We use the mutually exclusive formula. Why do I keep saying that? Because tonight for homework, they're going to mix up mutually exclusive in the second one. You got to read the question first, figure out is it mutually exclusive or the other one. If it is mutually exclusive, there's your formula. Probability of being odd is
4.
out of probability of a 2.
1.
Therefore, we add the 2 together and we get,
5.
and we're done. Yes,
We call the mutually exclusive event MEE for short.
we do. Yes. You're going to eventually see me do it as well. All right. By the way, you don't have to tell me it's mutually exclusive. You just have to choose the right formula. Okay? All right, we okay?
No?
You do. By the way, don't reduce the fraction until you get your final answer, because if you do, then you lost your common denominators. Okay? Nathan, do we get 5/8? Okay, you got this? All right. Well, that's half the class. The other half of the class is what happens if the two events can occur at the same time. Okay? Mutually exclusive events, great. Probability of A plus probability of B. The other one, we give another fancy name to it. These are two events that can happen at the same time. We call these overlapping events. Next box. Overlapping events. These are events that can happen at the same time. In other words, you can be both for and even. Right? That means there's two events that have something in common with each other. They overlap each other. Events that can happen together. I didn't actually count tonight for homework, but my assumption is about half of them are overlapping and half of them are mutually exclusive. Step number one for the, 7th time? Figure out if it's mutually exclusive or overlapping. That would be step one, yeah. Blue or white. Is that mutually exclusive or overlapping? Can they happen at the same time or not? Can you both be blue and white?
No.
So those are mutually exclusive. It looks like a word problem, but it's a really easy word problem, everyone. It's not. It's just find the word probability. Okay. We already know the formula for this one. We don't know the formula of this, but I'm going to take before I show you that formula, I just want to reinforce the fact that step number one is you got to figure out. So quickly, I'll show you 4 examples. Nathan, you got the first one. One game, one term. You have to figure out whether it's mutually exclusive or overlapping. Here's the game. One game, one term. Is that mutually exclusive or is it overlapping? Because there's two things that can happen at the same time. I can both be a 1 and a 6 at exactly the same time. So it's not overlapping, it's MEE, right? So we're going to use that other formula. I'm not doing a calculation yet. We're just determining whether this is like homework tonight. So then we use probability A plus probability B. All right, John, read. Mutually exclusive or overlapping? You can't be both yellow and purple. So MEE, mutually exclusive. Caden, read. It's on the board.
Yellow and purple. P1 on purple.
Read the one that we're on.
P1 on purple.
What does the P mean?
Probability.
Okay, probability of
1 or purple.
mutually exclusive or overlapping?
Overlapping.
Why is it overlapping?
Because you can get 1 in purple.
One is purple, so this one overlaps. So this one we're going to use the formula I'll show you next slide. Okay? Yeah? Grace? Mutually exclusive or overlapping? Okay, you can't be both even and odd. That one's mutually exclusive. All right, last one, Antonio. Can you be even and blue at the same time? So therefore, is it mutually exclusive or overlapping? Mutually exclusive means they can't happen at the same time. Overlapping means they can. Something overlaps, right? There's something on this category, there's something on this category, but these are exactly the same, so they overlap. They're equal to each other. That one's overlapping. You're going to have to do this tonight for homework. If you pick the wrong formula, you get it wrong. You have to figure out whether it's mutually exclusive or overlapping. Caitlin says it's a bit more complicated than this. Like there's so many words around it. Instead of saying this, there's going to be words that say, calculate the probability of the spinner being even or blue. Okay, it's basically this, just with some words around it. Okay, all right. Write this down. This is going to be the formula. The formula for overlapping looks an awful lot like the previous formula. There's one extra thing. It's underneath my hand. You are going to, that's box 5. You're going to subtract the overlap. This is the overlap. It's the part of the probability that includes the A and the B. That's why it says A and B. The overlap is the A and the B. Yeah.
Wouldn't it just equal 0 then?
It could if there's no possibility of it occurring. So the probability of getting a 7 or a 10 on a 1 die would be 0. 7 and 10 would be mutually exclusive. How about 7 or greater than 6? There's an overlap right there. But that would be 0 because neither one of those things could occur. You got a die. What's the probability of getting a 7 or a number that's greater than 6? Those are my 2 events.
Okay, but if it's like if your A is a 4 and your B is a number greater than 3,
then the only thing you're overlapping is one number, that's the number 4. So you're not going to subtract everything, just a piece of it. How about we do some examples? And that was one of the examples we're going to be doing, by the way. Okay. All right, everybody have it copied down.
Yes,
Once
sir.
again, the formula is harder and longer to write than it is to do. It's just 2 numbers added together, 2 fractions added together, subtract the second fraction. Third fraction. There, I said it right. Okay, so here is an overlap, 1 or purple. Yeah. If you're 1, you're also purple. There's an overlap. So Eleanor's instinct said, well, possibly we could get a 0. Let's see if that happens. Okay, it takes longer to write this down than it does to do it. These are 2 events that can happen at the same time. They're overlapping. So we use the overlapping formula. Nobody writes that down. Nobody writes that down. Look how long it would take you to write that down. The probability of 1 plus probability of purple minus the probability that you're both 1 and purple. Nobody writes it down. Okay, here we go.
What just happened? It turned green and then
I'm having a stroke.
that's not
Here we
a
go.
good thing.
Probability of 1.
1.
No.
1 over 8.
1 over 8. Probability of purple.
2 over 8.
Okay. Probability that you're both 1 and purple.
1 over 8.
And we're going to subtract that. So 1 plus 2 minus 1 is, you're done. We would change that to a quarter, but yeah.
I get it now.
Okay, good.
Okay.
And you're wearing purple, aren't you? Okay. Yeah, the overlapping is the one you got to be careful on. Let's do some more examples. Even or blue, mutually exclusive or overlapping?
Overlapping.
Overlapping. So we use the overlapping formula. You got to ask that as your first question because they're going to be mixed together tonight for homework. Okay, probability of even. Probability of blue. How many numbers are both even and blue? It doesn't say even or, it says even and blue.
2, 8.
Okay. Therefore, we get, which would give us, and you're done. Anybody lost? Not hard. Nelius? So you got the even part, you got the blue part. Now let's think. This says, I want you to be both even and blue. How many numbers are both even and blue? Out of 8 numbers, and that's why it's minus 2 over 8. So it's just subtract the parts that are overlapping. Yeah.
Does even include the entire circle?
It excludes any number up here.
Okay.
So 2, 4, 6, 8. There's 4 of them, right? All right. Odd or 8. Mutually exclusive or overlapping? Mutually exclusive or overlapping? Does everybody see that one's mutually exclusive?
Yeah.
There's no overlap there. You can't both be odd in the number 8. 8's even. So tonight for homework, that's what you got to do. Okay, now you just figured out it's MEE, right? So yeah, I finally did it. But then I wrote non-overlapping. All right, you do that formula and you're done. All right. Test review tomorrow.
Oh, goody.
Tomorrow is only Wednesday.
Oh my gosh.
That means after tomorrow, there'll be 2 days left.
Yeah, and then Laura's